Hello there. So today we talked about the different chromosomal aberrations that can occur because of non-disjunction during either meiosis 1 or meiosis 2. Well, there are also some structural chromosomal aberrations, so things that can make the chromosomes have a monosomy or a trisomy and result in different conditions. And so to start, we're going to look at our original chromosome here. So our original chromosome looks like this. This happens to be chromosome number 1. So the banding pattern is similar to what we see on chromosome 1 in the real world. And so the first one that we're going to talk about, the first structural differentiation, is going to be deletion. And deletion is exactly what it sounds like. So I lined up the centromeres on all of these. They're all on the same line, so we can see how things are affected. And so deletion, as you would expect, we're removing a chunk, and because we're removing that chunk, it is causing it to be smaller. And the chunk that we happen to remove, if we look at our banding pattern, we notice that there is a dark band here, a rather thick dark band, that is missing from over here. And so that is the deletion. And so the problem that this may cause is that now, as usual, we get one from mom, one from dad. So we get one from parent 1, one from parent 2. So if this happens to be parent 1 and I have parent 2, well, then I'm going to have, for this gene, for parent 2, I may have that gene. But for parent 1, there's going to be nothing. Sometimes this doesn't result in any problems and any difficulties. And so these are a little hard to notice sometimes, the chromosome differentiations. They're a lot harder to notice than a complete trisomy or a complete monosomy, where we're adding or removing the entire chromosome. And that's because depending on where it occurs, it may occur in a part of the DNA that codes for nothing, and so it doesn't matter, or it may happen at a place where by having just one copy of the gene doesn't cause any negatives. But it could happen in an essential part, and so this would cause a major malfunction. But that's what happens there, is we have a deletion. And so now, in our second one is going to be a duplication. And a duplication is exactly what it sounds like. It's going to be where our chromosomes duplicate. And so on my original chromosome here, I see a banding pattern of white, gray, white, black, white. Well, when I look at my duplication, I see that not only do I have the white, gray, white, black, white, but I have a second copy of it. And so this is why it's called duplication. And so again, now this is going to cause a problem, because we'll just look at one of these. But if parent 2 has an A on there, well, now you are going to have an A and an A, so it's going to lead to a trisomy of that gene. Again, that may cause a problem, it may do nothing. So that's duplication. Our third one here is going to be our inversion. And so our inversion is when we look at let me look real quick and see where I made this inversion at. Yep, it's up here. So when I look at my chromosome up here, I notice that I have a white, black, white, gray, white, black, white, and then my big black. But when I look over here, I notice that that big black band is on top, and that 3 stripe is on bottom. So it flipped. It just completely flipped upside down. So this became there, this became there. So this doesn't seem to cause as much of a problem, especially because we still have the same number of copies of each gene. So if this happened to be our A in this case, well, it's still there, so I still have it. Where this runs into a problem, however, is during crossover. If during crossover it tries to cross over with a similar gene, so if it tries to cross over with dad's copy of the gene, so if this were in meiosis, this would cause a problem, because it would cause there to now be 3 letters, because you would have the part here And when it crossed over, sorry, not 3 letters, when it crossed over, let's say that this one here is dad's chromosome. When it crosses over, it's going to cross over with gene B. And so now because of that, you will have a chromosome that has 2 B's and a chromosome that has no B's, because they would cross over. So that would only be an implication in that instance during meiosis, during the forming of the gametes. Otherwise, it can cause problems. It might not. But that is one thing that we have seen that does cause some problems, is the inversion or the flipping of a part of the chromosome. The final one that causes problems is often referred to as an incomplete trisomy or an incomplete monosomy. So with our incomplete trisomy, which is typically what ends up happening, is that the genes will swap, but they'll swap between different chromosomes. And so in this case, when we look at this, we'll notice that in my original, I have a white chromosome here, or white gene here, and I have a gray gene on chromosome B. So A has a white gene, B has a gray gene. Well, they swap those 2 genes. And so now A has a gray gene and B has a white gene. And so again, the problem with this is going to be is that depending on what gets copied or what doesn't, you may end up having a third copy of something. Because this is on, so for example, let's say that this happens to be B. Since this is on chromosome A and it should be on chromosome B, we're still going to have a chromosome B from parent 1 and a chromosome B from parent 2. We have a gene here because it's swapped, and so now I have a trisomy. I have 3 copies of that gene. And so again, this can cause some problems. I hope this helped to explain things. I hope it makes a bit more sense. I'll be looking forward to hearing any questions you may have.